Very good morning, students, all of you. So, today we can start a topic about physics, that is the system of particles and rotational motion. What is the name of the topic? System of particles and rotational motion. Okay. So, now, first of all, sir, what is exactly particle? We can see the different terms which involves into that system of particles and rotational motion, so that you will get the idea about that chapters very quickly. So, first of all, what is particle? So, this particle, the definition of particle is, we can say like this. It is defined as any object which have a finite mass and whose shape or size or internal structures can be neglected. So that is called as the particle. Okay. Means it can consider, suppose any body, if I will take this body and one particle if I will take which have a finite mass, this is considered to be a particle. Okay. Now sir, what is system of particle? What is system of particles? If you are collecting all the such a particles together, they forming a one system. What is that system of particles? The collection of all the particles, okay, which forms a one system. But in a such a way that all these particles are attached together and forms a body. That body we can further also call as a rigid body. So that is called as the system of particles. Okay. Once you got that particles and system of particles, so now question arises, how that all the particles combine together, how they holds with each other. You know that each particles, when they are combining, there is some intermolecular force of attraction is there. Okay. And so due to that intermolecular force of attraction, that is also called as internal force. All the particles, they are combined together and forms a one definite structure. Okay. Like as a crystal, regular arrangement of atom in a particular substance, that is called as a crystal. The same thing, how this regular arrangement is going to form, this is due to that internal force which is developed inside the body. Okay. So that what is that main role of internal force? Internal force just collecting all the particles together. Okay. So that is the internal force for that system of particles. Then now next term comes, sir, what is external force? Now suppose for that body which we have been formed because of that system of particles. Now any external agency which is acting on that particle, so that this particle comes into that motion, or which can changes the velocity of that body system of particles, that is called as the external force. Okay. So you try to understand in between these two forces, internal which holds that all the particles together and forming a system of particles body. But what is the external force? External force means this is the external agency which will act on that body, so that body comes into the motion, means velocity of the body can be get changed. So that is called as the external force. Okay, once you got the idea about all these four terms, then now we are going to apply that all the terms in a system of particles, that is in the rigid body. But before studying to the rigid body, you should have the idea about what is exactly non-rigid body. You see here now. The non-rigid body means the distance between two particles changes due to external applied force. Now what is going to happen, if you are applying the external force to that system of particles, to that body, and if the distance between these two particles is going to get changed, then that is called as the non-rigid body. For example, if you can take a clay, clay, have you seen the clay? Yes. So if I'll give the some external force to that clay, the distance between these two particles is permanently going to get changed. So therefore, that is called as your non-rigid body. Okay. So best example of non-rigid body is clay. Or if you can take a ball also, a sponge ball, rubber ball. If I'll press to that ball, okay, no doubt, after pressing, distance between two particles is going to get changed. Okay, so that is whether these particles they regain into original position or not, that is not the matter. But the distance is changing, so then at that time this is considered to be a rigid body, non-rigid body. Okay, so then what is rigid body, sir? Exactly, if I get the idea about the non-rigid body, sir, what is exactly rigid body? So rigid body means totally opposite to that. If the distance between two particles does not change under the action of applied force to that body, to that system of particles, then that is considered to be a rigid body. Okay, it's a very simple. If now I'll take a stone, if I'll take any duster, okay, you have the duster. Suppose if I'll take that duster and if I'll apply some external force to that duster, then the particles, the two particles of the dusters, they are not going to change their position, then definitely we can say that this is the rigid body. Okay, the stone having the same position. So therefore, the stone is the best example of rigid body. Okay, do understand now. A rigid body has some properties. Intermolecular force of attraction is very strong in that your rigid body. You remember that things. Okay, all the particles, they are regularly arranged. Okay. Then now that there is no perfectly rigid body is available in the universe, but that things also you remember. And if you want to learn the motion of that rigid body, you should have the idea about center of mass. So that also we are going to learn later on, but now that is the condition of that your rigid body. Some of the properties of the rigid body, you should have the idea about all these things. Okay, once you got the idea about that rigid body, then we are coming to the point, sir, what is exactly rotational motion? Because now system of particles is also called as the rigid body, and now we are going to learn about its rotational motion also. Before proceeding to the rotational motion, this motion is very interesting motion. But for that you should have the idea about the circular motion. Sir, what is the difference between circular motion and rotational motion? In circular motion, when the particle is moving along the circumference of circle, then that motion is called as the circular motion. But in rotational motion, when that system of particles are moving, means when the rigid body starts rotating, then all the particles are moving in a circle, then that type of motion is called as the rotational motion. Do you understand the idea about what is the rotational and what is the circular motion? In circular motion, only one particle is moving along the circumference of circle. But in rotational motion, all the system of particles are moving along the circle. So this type of motion is called as the rigid body. Suppose if we can take the example of Earth. Earth rotates about its own axis. Now Earth is made up of large number of n number of particles, and when all particles are moving along the circumference of circle, the different circles, then at that time this motion is called as the rotational motion. You understood that one particle, if I take the Earth of the Earth, then that is the circular motion when it is moving along the circumference of circle. But when all particles are moving together or revolving together about one particular fixed axis, then that is called as the rotational motion. So then question is, sir, what is that axis of rotation? Because when this body moves, then about some fixed line, so that line, imaginary line, we are going to definitely call it as a axis of rotation. So then define what is exactly axis of rotation. So axis of rotation is an imaginary line which is passing through any that rigid body about which the different particles are moving in a different circles. So that line is called as axis of rotation. For example, if I take Earth, Earth have its own axis. So that axis means, suppose if I consider it as an imaginary line, then all the particles of the Earth, they are rotating about that axis, that imaginary line. So therefore, this is considered to be an axis of rotation. This is the vertical axis. No doubt, if I take any another part, suppose Earth, if I will start rotating like this also, then diameter, so your horizontal diameter will also considered as the axis of rotation. If the Earth rotates like this, then your vertical axis is considered to be an axis of rotation. Are you getting this point? Okay, so all the particles are revolving in a different circle. Okay, different particles in different circles about that particular one imaginary line. That line is called as the axis of rotation. Once you got the idea about axis of rotation, then now you are coming to the point, sir, what is exactly the center of mass of the body? Because we want to learn the center of mass and its motion. Now, sir, what is exactly center of mass? Now, whatever the system of particles or rigid body that we have considered, then whole mass of the body is supposed to be concentrated at one particular point in order to study of motion according to Newton's laws of motion. So that point is called as center of mass of the body. Sir, what is the meaning of that statement? Meaning is that, so that body which is made up of number of particles, so at one particular point whole mass of the system of particles is supposed to be concentrated, and if you are applying the force to that body comes in a translatory motion. We can describe the translatory motion means body moves along the same straight line in a forward direction when you are applying the external agency, external force to that point. So that is called as the center of mass of that particle. Okay. Once you got the idea about the center of mass, then we are coming to the point, sir, what is exactly center of gravity? Okay, center of mass and center of gravity. Okay, so now before that center of gravity, sir, what that center of mass, sir, what are the units and dimensions of center of mass? So center of mass is the distance. So therefore it is measures in meter. Some of the students they can consider, sir, this is the mass, so therefore it unit will maybe kg or gram. No, this is the one particularly point about the center of mass. So therefore about one particular line. So therefore center of mass measures in meter in SI system or centimeter in CGS system. Okay, and the dimensions of that center of mass will be m0, L1, t raised to 0. Remember that thing, this is all about center of mass. Now you are coming to the point, that is what is, sir, center of gravity. Now center of gravity is the point where whole weight of the body is supposed to be concentrated at one particular point. So that is called as the center of gravity. Now if you can consider small mass as the center of mass and center of gravity will be the same point, because only what is the difference, when you are multiplying that mass to that g, it will become center of gravity. But now you know, interesting fact is that for a large body, center of mass and center of gravity does not coinciding with each other. For example, Mount Everest. Okay, so the Mount Everest center of mass and center of gravity is the different point, because here in case of Mount Everest, center of gravity will be lies just below the center of mass of that Mount Everest. Why do you know? Because from the surface of earth, as we are going, that means move in a forward direction or in a upward direction, then at that time gravity goes on increasing. So therefore as the g will be goes on decreasing, the center of gravity will also goes on increasing. So that will be the condition, and for center of gravity, w can be written as m1g plus m2g plus so dash 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 mn into g, and if I'll take g common, m1 plus m2 up to dash dash mn, and so here this is the total mass, so therefore mass into g, that will be the center of gravity. Okay, so these are the different terms which are involved in a system of particles and rotational motion. Now we want to learn the center of mass of two particle system.